Hello and welcome. This is our lecture video for September 10th. Just a reminder, this video is for Cohort A. Cohort B, you'll be getting this lecture in class. If you want to watch it twice, that's fine, but you don't have to. This is really just for Cohort A to stay on track with Cohort B. All right, so you should have your notes out. What I want you to do is rewrite this poem at the top of your notes. It's an acrostic poem. And then explain what it means to you. Here, I'll read it once. The word down the side is math. And what it says is, mistakes allow thinking to happen. All right, so what does that mean to you? Goal for today is to understand a few rules of divisibility and how to calculate exponents. While we're doing this, so we can quickly tell if one number divides into another number evenly, and so we can do PEMDAS correctly. All right, exponents. Let's write down an example of an exponent. We'll do 2 to the 4th. That 2, we call that the base, and then the 4, we can call it the exponent or the index, or the power is another word for this. So draw this little diagram, and then this here tells us how many times to multiply the base by itself. 2 to the 4th means 2 times 2 times 2 times 2, which equals 16. And this diagram really should have used dots for multiplication. They used the outdated x. In your own notes, why don't you write that with dots? All right, let's try another one. What is 3 to the 4th power? Well, what this means, we take that base, 3, and we multiply it by itself the number of times in the power. So 3 times 3 times 3 times 3. Now when you're doing this multiplication, you can go left to right, or you can pair off the 3's. So do 3 times 3 and 3 times 3, so we turn this into 9 times 9. And then we get that to be 81 in one fewer step. All right. So 3 to the 4th is 81. All right, these are the first 3 questions on your worksheet, so hopefully you've got that out as well as your notes, because we're going to do a couple off the worksheet, but the ones that aren't on your worksheet you can just do in your notes. What's the difference between negative 2 to the 4th and, in parentheses, negative 2 to the 4th? Well, let's expand these out. Negative 2 to the 4th, that negative is actually a multiplication step and comes after the exponent in PEMDAS. So what this one means is negative 2 times 2 times 2 times 2. Versus this one here, negative 2 to the 4th with the parentheses, this means negative 2 times negative 2 times negative 2 times negative 2. And if we calculate these, 2 times 2 is 4 times 2 is 8 times 2 is 16. The negative stays in front. This one is a negative 16. But negative 2 times negative 2 is a positive 4 times negative 2 is a negative 8 times negative 2 is a positive 16. So they equal different things. All right, and you should explain that with words as well in this first step, as well as showing that they are different. All right, next rule, 1 to the power of anything is equal to 1. For example, 1 to the 5th equals 1 times 1 times 1 times 1 times 1. 1 times 1 is 1, times 1 is 1, times 1 is 1, times 1 is 1. So it doesn't matter how many 1s you put in a row, it's always going to be 1. Anything to the power of 0 equals, this is one you have to just memorize. It's also equal to 1. So like 5 to the 0. Multiply 5 by itself 0 times. It's kind of confusing, doesn't really make sense. So we just say, by definition, it's equal to 1. All right. Evaluate each expression. So we still have to follow PEMDAS, which means these parentheses go first. In problem number 6, we got to do the 5 minus 3 first. That becomes a 2. Now we can drop the parentheses. 2 squared means 2 times 2, which means 4. Here the exponent goes first because there's no, you cannot simplify what's inside the parentheses. So this just becomes negative 4 minus, and I might keep this in parentheses, negative 2 times negative 2. Turn that into negative 4 minus, still in parentheses, negative 2 times negative 2 is a positive 4. Now maybe I can drop the parentheses. Negative 4 minus 4 is a negative 8. That was a tricky one. Problem number 8, negative 4 minus 1 squared. Here, this minus is not being part of what's being squared, so this just becomes negative 4 minus 1 times 1. Negative 4 minus 1 becomes a negative 5. So there we see the negative getting left out. Here, the negative is included. This becomes negative 2 times negative 2 times negative 2 minus 4. I'll just do these one at a time. That becomes a positive 4 times negative 2 minus 4. That becomes a negative 8 minus 4. That becomes a negative 12. All right, so now we're going to start talking about divisibility, which means we need to know what the definition of a whole number is. A whole number is a positive number without a decimal. That's what makes it whole. So 7 is a whole number. Maybe I'll write that in green because it's a good example. So 7 is a whole number. All right, 7.1, now you have this extra piece. So the 7 might be whole, but this 0.1 is not whole, which makes the whole number not whole. So a positive number, oh, I wrote with a decimal. That's the exact opposite of what I meant to say, without a decimal. All right, divisibility. What does it mean for a number to be divisible by another number? All right, if the number can be divided, say if the first number can be divided by the second number without a remainder. All right, so let's see, does 4 go into 72 evenly? All right, so does the 4 go into the 7? Yes, one time. Subtract away, 3 left over. Does 4 go into the 32? Yes, 8 times. That's a 32, subtract it away. This is our remainder. So no remainder. And that means that 72 is divisible by 4. All right, let's go through a few divisibility rules. The rule for 1. Here's the rule for 1. It's very easy. Everything is divisible by 1. So 1 should be included in all of our lists if we want to list down all the numbers that divide it evenly. And when I say everything, I mean every whole number, but we don't talk about divisibility when we start with a decimal. All right, rule for 2, the number must be even. And that word even means it has to end in a 0, 2, 4, 6, or 8. So which of these numbers is divisible by 2? All we have to do is look at the last number. This one ends with an 8, so it's good. This one ends with a 7, that's an odd number, so not good. This one is, this one is, this one is, this one's not. This is a number in the millions. We don't want to have to calculate this, but all we have to do is look at that last digit, and it's an 8, so this one's good. And 0 is, yes, technically even and technically divisible by 2. All right, these two didn't work because they ended in a 7 and a 5. All right, the rule for 3 So you're going to add up the digits. If the result is divisible by 3, then the original number is 2. So if we've got a number like 891, you turn this into 8 plus 9 plus 1. You turn this into 18. If you're still not sure, do it again. Turn that into 1 plus 8. That turns into a 9. So this is divisible by 3. Is 456,704,219 divisible by 3? Without a calculator, I can figure this out. I just go 4 plus 5 plus 6 plus 7 plus 4 plus 2 plus 1 plus 9. I'll pair these off to add it quicker. So 9 plus 13 plus 6 plus 10. Pair them off again. 22 plus 16. Still not sure. Add them together again. We get 38. And this doesn't look like it's divisible by 3, but we can run the same system again. Do 3 plus 8. Add them together, we get 11. So the answer is no. No, it's not divisible. All right. Rule for 4. Rule for 4 is check the last 2 digits. If just the last 2 digits are divisible by 4, then the whole number is divisible by 4. So is 560,760,568 divisible by 4? We only check the 68. And we can do this long form if we want. 4 fits into 6 one time. 4 fits into 28 7 times with no remainder. So this is a yes. All right, because we got no remainder there. And we only have to check the last 2 digits. Rule for 5. If the number ends in a 0 or a 5. If it ends in one of those 2 numbers, then we know that the whole number is divisible by 5. Rule for 6. So if the number is divisible by 2 and 3, then 6 automatically works. So use the rule for 2, which is check and see if it's even. Use the rule for 3, which is add up the digits. If it passes both, then it'll also be divisible by 6. So is 559,192 divisible by 6? So it's even. So 2 works. So we're halfway there. Now to figure out if it's divisible by 3, we got to add up the digits. This becomes a 9. This becomes a 10. That becomes an 11. 19 plus 11 is 30. 30 is divisible by 3, so 3 works. Therefore, yes, because 2 and 3 both worked. Therefore, 6 has to work. All right, the rule for 8 is you check the last 3 digits. It's not a great rule, but it can save you some time if you've got a really big number. The rule for 9, is add up the digits, but this time divide by 9. So add up the digits and divide by 9. If you get a whole number, the original number is divisible by 9. Rule for 10, it has to end in a 0. All right, and you've got lots of practice for this on the back of the worksheet that's titled Exponents. The back side is all about divisibility. So good luck with that. Finish up that worksheet. Have a good rest of your